to record, so you will have the recording available for you to review if needed. So I did start the recording now. So generator limit constraints should be taken into consideration in this optimization problem, and also for each bus this balance should be satisfied, generation and load. It introduces voltage, magnitude and angle for each bus into the problem. You have to keep the voltage magnitudes at within certain bounds, and also you need to keep the angle. What do you think? Any clue about the optimal angles? Let us say optimal angles. If we keep the angles at a certain value, this would be an ideal case actually. What 90, do you think? Do you have any?
90.
90. Any other suggestion?
120.
0.
Yeah. Okay.
The angle 40, Doctor.
About what? 40?
I think, Doctor, if we deal with the per unit, we will not have angle, right?
No, the angle is there, even if it is in per unit. The voltage magnitude will be in per unit, يعني 1 per unit, 1.1 per unit, but the angle should be there. The angle has nothing to do with the per unit quantities. Actually, the angle, if you keep the angle, as low as possible. So that means
power factor, right?
Power factor, this is 1. Real power and reactive power, this is 2. If you keep the angle is 0, so this would be the optimal case. There is no reactive power flow, and reactive power is a burden. It is needed, but it is a burden. And the power factor correction. So if you have like a load here, this is a generator, you have a transmission line, and you have a load here.
Capacitor in parallel.
In order to improve the power factor or reduce the reactive power flow, so then you have to have, yes, a capacitor here. So this capacitor will generate the reactive power needed by this load locally. You don't need to have the reactive power comes from the generator all the way through the transmission line to your load. But in industrial plants, they install power factor correction capacitors here in order to generate the reactive power locally. So what they need from the Saudi electricity company, they need only the real power. So this will reduce their bill. This will reduce also the loading of this transmission line and will improve the power factor here, maybe to unity or to 0.95 lagging. Depends on how much the reactive power comes from the capacitor and how much the reactive power of the load. So this is very important. To keep the angle between this bus delta 1, you have here V1 with angle delta 1, and you have here V2 with angle delta 2. If you keep delta 1 and delta 2 as low as possible, that means you have very low loading of this transmission line, and your system is more secure in this case. Also, the equality constraints of this problem in all buses, you have to check the voltage magnitude and angles. So in this case, you have 2 times n minus 1 except the slack bus and so on. So no need to go in details in this.
دكتور
Yes, please.
بالنسبة لإرسال الباور لمسافات بعيدة الرياكت باور راح يصير لوسس عليه أكثر من ريل باور؟
مش فكرة losses in more than real power or so. Actually, okay, let us say here, if you have a transmission line, this is a generator V1 with angle delta 1, and you have V2 with angle delta 2. Okay, assume that you have here B plus JQ. How much B, how much Q? If you have the voltage here V1 with angle delta 1, the voltage here V2 with angle delta 2, and for simplicity, let us say that this transmission line has a reactance X. This transmission line has a reactance X. The resistance is almost approximately 0, especially for high voltage transmission line. The ratio X over R is approximately 10. So you can neglect the resistance. Assume that you have the reactance of the transmission line, and these are the voltage at both buses. How much the power flow B12 and the Q12 here? Simply, if you get the current here, I equal to V1 with angle delta 1 minus V2 with angle delta 2 over
X.
over what?
X.
X ولا JX؟
JX.
طبعا طالما بنتكلم عن complex numbers, this is the impedance JX. So this is the current. Okay. How much this S12? S12 here equal to V1 times I conjugate.
Yes.
Okay. S12 equal to V1 with angle delta 1 times I conjugate. Of course, in order to simplify, instead of having the conjugate of this quantity, we can get only the conjugate of this quantity. So we can take the conjugate of both sides. So we can write here S12 conjugate equal to V1 with angle minus delta 1 times I1, which is V1 delta 1 minus V2 delta 2 over Jx. Okay, so this is equal to V1 with angle minus delta 1 times V1 with angle delta 1. So it becomes what? V1 square minus delta 1 times delta 1 خلاص goes together. Okay, minus V1 V2
Delta 2 minus.
Sorry?
Yeah, delta 2 minus delta 1.
Delta 2 minus delta 1, exactly. So this is the S12 conjugate. Right? So can you remove this J from the denominator? So you can write this quantity as minus J V1 square X, over X, minus J, so this will become plus J, V1, V2 with angle delta 2 minus delta 1 over X. Are you following me? Is it clear?
Yes.
Now we just we distribute V1 square over Jx, and this quantity over Jx. طبعا J will go up with minus J, so it becomes plus J. So can you expand this delta 2 minus delta 1 to cosine and j sine?
Yes.
So we can write S1 2 conjugate here as minus j v1 square over x plus j v1 v2 over x times cosine delta 2 minus delta 1, right, plus
sine delta 2.
sine delta 2 minus delta 1. طيب, keep in your mind that this is equal to b12 minus jq12. This is the conjugate.
Yes.
So you can now write what is the real part of this quantity. What is the real part?
Minus sine.
Minus
v1 v2 over x sine.
Okay.
J times j.
v1 v2 over x is sine
delta 2 minus delta 1.
Delta 2, okay, this delta 2 1. Okay.
Yes.
طيب, how much Q reactive power?
v1 square over x.
v1 square over x. Okay.
Yes, and plus v1 over v1 v2 over x cosine.
v1 v2 over x cosine delta 2 1. This is minus, so yes, this will be plus and this will be minus. Okay. Now, if you look at this, B12 is the line flows, the power flow here, right? So if you minimize this angle, if this angle is 0, there is no phase shift. So how much is the line loading?
V1, V2 over X.
No.
Will be 0.
If delta 2 equal to delta 1, يعني delta 2 1 equal to 0, so B1 2 equal to 0. If this is good or bad from power system point of view?
Bad.
It's bad.
Bad.
Very bad.
Bad. Our target Q should be.
لا, يعني ليه very bad? يعني if the line flow is very low, for the current situation you have very low line loading. Is it good or bad? يعني انت عايز الترانسميشن لاين يبقى heavily loaded؟ ده يعني يسعدك يعني ان يبقى الترانسميشن لاين على كافة الهوية بتاعته؟
لا.
يعني لو الترانسميشن لاين ده 100 ميجا فولت امبير لودنج، لو انا ماشي فيه 10 ومغذي اللود بتاعي، كويس ولا وحش؟
10 كويس.
Very secure. ليه very secure؟ لانه if we have any disconnection we still have very long margin to reach to the capacity of the transmission line, right? يعني if the line loading is very low, this will enhance the security of the system. And if we have any disconnection, you still have 90 megawatt to be injected in this transmission line without any problem. And if you have the transmission line 100 mega, يعني at full capacity, and if you have a disconnection anywhere, one transmission line is out, so the power flow will increase here, and your system in this case will not be secure. Am I right?
Doctor, isn't it B12 minus V1 V2 over X?
B12 is should be
down.
We have to bring it from here. يعني you have to V1 minus delta 2 over 2jx. V1 times this is conjugate, so we have S12. This is V1 minus V2.
Doctor, just the multiplication of G and G, isn't it minus 1 G square?
Yeah, G square is minus, yes.
Yeah, and S12, then B12, isn't it? We multiply J V1 V2 over X V in G sine, so
Minus,
it should be minus.
Okay, if this is the, yani, we have to, yani, supposed to
consume and produce.
injected. Maybe you can look at it as injected power.
Yeah.
يعني to the system. يعني. But anyway, يعني, this sign is not that much important. It reflects the direction. Okay, it reflects the direction of power flow. We say B12, so we look at the power from bus 1 to bus 2. B21 will be minus this quantity and so on. So this minus reflect the direction. Okay, direction. Now the quantity is here. Quantity is here. If this angle, we need this angle to be very, very low. The optimum to have the angle is 0. That means you have very light loading conditions, and the system is very secure in this case. طبعا reactive power, as you can see here, it depends on this cosine, this angle. If this angle, you know, if this angle is very low, then you have here the difference. Here you can, this, if this is 0, okay, V1 almost equal to V2, let us say. يعني دايما الفولتج in power system, they are very close to 1 per unit, or very close to the rated. So this one also is V1 square over X.
0.
Look
Then
at it as such.
V12 0.
So if delta equal to 0, that means in the Q12
0.
0. What means انه there is no reactive power flow in this case, right? Is it clear?
Yes.
Okay.
Doctor.
Yes.
Regarding the last point, Q12, how it becomes 0 if delta equal to 0?
Cosine 0 equal what?
1.
And V1 approximately equal V2. We said
V1 approximately equal to V2. In power system, usually the voltage is at almost the rated.
Okay. Got it.
Okay. Type. So this is the case of the power. Yes. Any question? We need to,
yes, I have a question.
Please raise your hand.
Can you please explain again what do you mean by a secure distribution, line distribution?
Security is to keep the system, you know, healthy. حتى even if you have generator outage or transmission line outage, even under these disturbances, there is no violation. There is no overflow in any transmission. There is no over voltage or under voltage in at any bus. This is what we mean by security. Under outage, simply under outage of any component in power system, there is no violation. If this is the case, the system is secure. Okay. If you have in steady state, if you have a line flow is very low, you are far from the capacity of the line, so your system in this case will be more secure. And even if you have an outage anywhere, the line flow will increase, but you still have a margin to its capacity. Is it clear? Am I right?
Yes. Yes, sir.
Okay. So this is what we mean by the security. And the state estimation, this is another problem. In simple words, we can say the idea is use measurements to figure out the state, that is voltage magnitudes and phase angle of an operating power system. As we mentioned earlier, and we cannot install the current transformer, voltage transformer at each substation. We have only some measuring substations, Based on these measurements, we need to estimate the voltage magnitudes and angles. So we can measure the voltage magnitude by voltage transformer. We can measure the real power. We can measure the reactive power. We can measure the ampere flow, the current. And based on these measurements, we need to estimate the voltage magnitude and the angle at all buses. If you know the voltage magnitude and the angle at all buses, as you covered in circuit analysis, it is a nodal analysis. If you know the voltage at all nodes, then you can find the losses, you can find the lower line flows, you can find the generation outputs, real and reactive power. You can have the clear picture about the system. So this is the idea of state estimation. The last problem in our course is the automatic generation control, AGC. Automatic generation control, we need to keep the frequency to 50 or 60 hertz. Okay. طبعا in Kingdom, as you know, the frequency here is 60 hertz. And we need to keep the frequency here in 60 hertz, like in the US and so Kingdom. But in other countries, as you know, it's 50. Most of the world is 50 hertz. Europe, حتى even the Gulf country, other Gulf countries is 50 hertz. Kuwait, Qatar, Bahrain, Oman, UAE, all are in 50 hertz. So anyway, you need to keep the frequency at the rated values.
Doctor.
Yes.
We know that the network is connected even to Bahrain. I mean, the electricity network is even connected to the system of Bahrain. Bahrain is using 50 hertz in their in the home. So how the 60 hertz here in Saudi Arabia is converted to 50 in Bahrain in the transmission line?
Yeah, good question. Does anybody have an answer for this?
DC
Yes.
first
We use
Just raise your hand and I will call you. Abbas Said?
Yes, doctor. By using power electronics to convert it the electricity to DC, then convert it back to AC with the required frequency. Okay,
great. Okay, this is the answer. Actually, this is the case in when you have different frequencies. You have here Kingdom 60 hertz, and you have here Bahrain or other GCC countries 50 hertz, whether Bahrain or others. Here you have to convert this AC to DC. So you have here AC to DC conversion. And then DC to AC, 50 hertz. And you have here 60 hertz. And in between you have here DC. So this is the case, الأخ اللي بيسأل. This is the case. You have to convert AC to DC and DC again to AC with the required frequency, which is 50 hertz here. Okay, this is bidirectional, and you can export power to Bahrain, and also Bahrain can export power to you. This is bidirectional power flow. And this is bidirectional flow. Okay. In Saudi Arabia here, you have this substation. We are talking about substation here. This is in Fadli, in Saudi Arabia. This is Fadli substation, which connects GCC countries, whether Bahrain or others, to Kingdom transmission system. This is in Fadli substation. you have the substation, you have a converter and the inverter on one side, converter on the other side, and you have a very short DC link. And you are talking about few meters between this converter and inverter here. So this is the way to convert from 50 hertz to 60 hertz. And also this, by the way, this is also the plan to connect Saudi Arabia to Egypt. They will connect the two networks, 60 hertz in Saudi Arabia and 50 in Egypt, by HVDC. HVDC, low high voltage DC transmission line. The DC link here is not just a few meters, but it's a very long transmission line. One converter will be in Tabuk, in Saudi Arabia, and the other will be in Egypt. And in between, we have long transmission line. You are talking about 500 kilometer or so, or 200, 300 kilometer in between. One converter in country and the other in the other country. But of course, here you have very close links. So you have a substation here, and you have a back-to-back conversion, as we mentioned in Fadli. So you can either back-to-back conversion or HVDC. You can connect 50 hertz with 60 hertz. The objective of the automatic generation control is to keep the system frequency to its rated value, either 50 or 60 hertz. How to do this? This is the way. You collect the measurements from the generator outputs, generator outputs, and you have system frequency also. You connect, you measure the generator outputs, you measure the system frequency, you measure the inter-tie lines flow. If you have this bar system is connected to neighboring, neighbor utilities also. You have transmission lines between مثلا eastern province or eastern area, Riyadh. We have tie line between Riyadh and Medina. We have tie line between Riyadh and Dammam. So these are the tie lines between areas, between utilities. Okay. So you measure also this power flow through this transmission line, and you have here like a BI controller. You have a BI controller to measure delta F, lower deviation in frequency. What is the cause, or what is the cause of this delta F? What is the cause of this? Why makes the frequency deviate from its nominal value of 60 hertz?
Because the load. Because if the load will increase, then the frequency will decrease. So there will be some changing in the frequency.
Exactly. If the load increases, the frequency will decrease. If the load decreases, the frequency will increase. So if you increase the load, then the frequency will be lower than 60 hertz. So this controller, BI controller, will measure the the deviation of the frequency, deviation of the power flows, and so on, and then it will correct this by increasing the generation of these generation plants. It will send a control signal to increase, to allow for more steams for to the turbine, or decrease the steam to the turbine if you want to reduce the frequency, and so on. So this is the control loop, which is the automatic generation control. This is done automatically, as you know, the switching of the loads is continuously. So you cannot find, and if you go to the control center of one of the utilities, you will not get the frequency 60 hertz constant. 60 hertz as such, no. The frequency will be like deviation around the oh my God. So you will show the frequency as such. 60.01, 59.99, and so on. So you will find the frequency oscillating around 60 hertz. Let me ask you, yes, please.
BI stand for what?
Proportional integral controller, where the transfer function will be as such, KB plus KI over S. Probably you still taking EE467 this term. If this is the case, when we reach to this, you will be able to know what is the implication of this generation control issues. Is it clear? طيب. So the objective of the automatic generation control is to restore the frequency to 60 hertz. Let me ask you before going forward, how much the minimum frequency allowable? Any guess? Okay, power system operator before protection issues to operate. لأن البروتكشن ده ده الحل الجراحي. البروتكشن ده في الباور سيستم هو الحل الايه؟ الجراحي. عندك مشكلة لو الريلي اشتغل، الريلي بيفصل على طول. في جنريشن بلانت الفريكونسي بتاعها بقى 60 او زاد عن ال 60 at a certain limit it will be disconnected and this will be very harmful. فاحنا we need to avoid الحل الجراحي ده. We need to avoid the relay to operate. Before the relay operation, we need to take measures. We need to take an actions in order to remove the the disturbance in the system before the relay operation. طيب, let me take the answer from Ahmed Fahd.
You mean the minimum error and the frequency?
Yes.
I think 0.5.
0.5 means you are talking about the frequency ranges between F minimum to F maximum. So you are saying that the frequency ranges from 59.5 to 60.5.
Yeah.
Any other different answer?
Yes.
خلاص أحمد فهد, lower your hand please. عدنان محمد.
59.95 to 60.05.
Oh, you are talking about here 95. 59.95.
Yeah.
And 60 point ايه بقى؟
05.
05. Okay. What else if you have different? محمد حسن.
Yes, 10%, I think.
10%, 6 hertz.
Yeah, 6 hertz.
You are taking 54 to 66. طيب, صالح عبد الله.
Yes, 10%.
Oh, 10%. Okay. طبعا 10% is very, very high and it's not allowable. This range is very, very tight also, which is not practical. This could be the range of the allowable frequency. You can allow for plus minus 0.3 hertz. And you are talking about 59.7 and 60.3. حتى even this is up to the protection. The protection will operate beyond this bounds before reaching حتى even to these bounds. We have to take a proper action. If it is 59, if the frequency reaches 59.9, then the power system operator should take an action here. And this action will be like load, what we call in power system, load shedding. Load shedding. The power system operator will send the signal to switch off some loads. Residential area مثلا, residential area is not يعني that much important. So if there is a deviation in the frequency here, then they will switch off some of the residential areas. And if the frequency is still going down to 59.8, for example, in this case, the power system operator will switch off additional loads. So we have some scenarios for each utility. Each utility has scenarios for load shedding. If the frequency reaches to this value, I will disconnect 10% of the load. If it reaches to this value, I will also disconnect 10% more, and so on. We need to avoid relay operation. If the disturbance is very severe and we cannot do anything, then the system will, the generator will be disconnected, and this will make the system even worse. We may go to blackout under this condition.
دكتور.
Okay? Yes, please.
بالنسبة للود شيدنج يعتبر آخر الحلول أو يعني
هو دي الحلول، يعني دي الحلول، هي آخر الحلول هي الحل الجراحي زي ما قلنا اللي هو الريلي اوبريشن. انما قبل الريلي اوبريشن we need to avoid الريلي اوبريشن by doing some load shedding. يمكن المشكله تتحل لو طفينا على الريزيدنشال اريا. الريزيدنشال اريا يعني مش
generate more power. Generate more power. Is that fine?
Generate more power. You are okay, great. كويس انك انت اجبت قلت الكلام ده. التايم فريم. How much is the time frame? We are talking about. يعني أنا الفريكونسي is going to 50-60 hertz and then it drops in maybe in 1 second or so. يعني كل التايم في المنطقة دي كلها 1 second or 2 seconds or 3 seconds or 1 minute. هل هتقدر تزود الجنريشن بتاعتك in 1 minute؟
لا طبعا.
It's very difficult طبعا. The time frame here, you know, governs which solution you have to take or you have to apply. طبعا الجنريشن ده يعني of course if you have a very wide range of time like 10 minutes, 20 minutes, then you can start up one of the gas turbine to cover the increasing of the load, but here it is very crucial and the time frame is very limited. You cannot start an additional generation here. Okay, so we need to restore the system frequency. You have Malik Ali Hassan. Do you have any question, Malik, or any?
Yes, I have a question about the allowance of the frequency. Is it decided by the engineers in the lab where they're trying the trial and error, or it is based on facts, scientific facts, or some concept behind it?
Of course, طبعا يعني this needs it is not يعني this is power system operator responsibility in any utility. Experience how much the loads, how much the critical loads, how much the non-critical loads, and if the frequency as such. If we have 5% disconnection of load, would it be possible to remove this deviation of the frequency, or we need to increase the percentage to 10%, and يعني this is scenarios that should be set by the power system engineers. Okay, each utility has its own policy here. Is it clear?
Yes, yes, it's clear.
Okay. طيب, let us move forward. So the responsibility of this problem, automatic generation control, is to reallocate the generation to keep it at economic dispatch. يعني you have increase of load of 100 megawatt. Again, how to distribute this 100 megawatt among the generators. يعني the generator was 60, now we raise it to 63 or 65 or 70 and the other one and so on. So we need to keep the system operating at economic dispatch issue. Keep interchange with other control areas at the scheduled megawatt. Of course, there are some contracts between the utilities, especially if you have, for example, countries, Saudi Arabia with Bahrain and so on. So if Bahrain asks for 100 megawatt, so Saudi Arabia should be committed to supply 100 megawatt to Bahrain, and this is contractual basis. So we need to keep the power line in the tie lines between utilities or between the areas or between the countries at the scheduled megawatt. So this is the also one of the responsibility of the automatic generation control. And of course, we have ramp up, ramp down, so we need to increase and decrease the generation according to the load. Any question? طيب, okay, let us move to the few minutes كده to periodic systems. This is the typical power system. You have some generation plants here, thermal station, and you have nuclear station, you have hydro station. Do we have nuclear station here in Saudi Arabia?
Not yet.
Yes,
No.
we will have soon.
We have.
We will have soon, and we are. I think.
We will have soon, yes. There is a plan for nuclear power station. But do we have hydro station? Any answer? Do we have hydro station here in Saudi Arabia?
No.
No.
Exactly, no. الهيدرو station is associated with the waterfalls, المساقط المائية in Canada, in Brazil, in Congo, in Africa, China also hydropower, US also, they have hydropower. If you have waterfalls, then you have hydropower station. In Egypt also we have high dam hydropower station, السد العالي, محطة السد العالي. It generates about 2 gigawatt of electricity. بس طبعا الكلام ده كان قبل سد النهضة بتاع اثيوبيا، انما ما نعرفش بعد السد النهضة بتاع اثيوبيا ده هيبقى الوضع ازاي. طبعا هيقل الهايت بتاع الووتر، ولما يقل الهايت يقل الباور جنريشن. واثيوبيا ناو دي انستول ما يقال سد النهضة in order also to generate electricity from the waterfalls there. So usually the voltage here for thermal power station is 13.8 kilovolt. This is the generated power at 13.8 kilovolt. So in this case, for the transmission line, you need to increase this voltage to 380 kilovolt in Saudi Arabia. This is the maximum. There is a plan also to increase this voltage level 765 kilovolt. We have also 230 here in Saudi Arabia, 230 kilovolt. 115 kilovolt, or 132 in central. All these standard limits for transmission. So we need to have a high voltage substation to 115, increase from 13.8 to 115, or even 765 kilovolt. You have here switching very large consumers. If you have مثلا Aramco, Aramco could be connected to some of the plants connected to at 230 kilovolt or 115 kilovolt. Also in Jubail industry, you have 230 kilovolt, or the city, Jubail city is supplied by 380 kilovolt. But you can find مثلا Safco, Sabic, Hadid, all this supplied at 230 kilovolts. So this is the very large consumers, industrial consumers. And then you decrease the voltage here to maybe 69, and you have other industrial plants connected. You can have the voltage up to, by transformers, you can decrease the voltage to 4 or 34.5 kilovolt, and you can go down to even 240 volt and 120 volt, and this is your home or the residential area here. So this is typically the power system, and different voltage levels, as you can see, and you have so many transformers. And this system, if you use the actual values, kilovolt, kiloampere, ohm, megavolt ampere, megawatt, and so on, this would be very, very, very difficult to analyze. And in order to simplify the analysis, we will go to what we call the per unit system. If you still remember in 360, you have the transformer, and if you have the transformer, then you have a very difficult to refer to primary or refer to secondary. You multiply the current by A, or divide by A, or you multiply the impedance by A square, and you convert from here to there. A transformer is a problematic device in power system. In order to remove this difficulties, we go to the per unit quantities. In per unit quantities, the transformer will be just represented by a reactance. The current in per unit in primary هو equal to the current in per unit in secondary. The impedance in primary equal to the impedance in secondary in per unit. Okay? So the per unit quantities is used in power system analysis. We cannot use just the actual numbers. The key problem in analyzing power system is the large number of transformers. You have step-up transformer, and then you have step-down transformers, and so on. So you have several transformers there. It would be very difficult to continually have to refer impedances to the different sides of the transformer, as we mentioned. This problem is avoided by normalization of all variables. We relate all variables to the normal values, to the rated values, or what we call to the base values. Okay? Normal values or base values or rated values, they are synonymous. So this normalization is known as per unit analysis. In order to normalize, this is simply the case. The quantity in per unit equal to the actual quantity over the base value of quantity. يعني the current in per unit equal to the actual current in ampere over the base current in ampere. The voltage in per unit equal to the voltage in volt over the base voltage in volt. S also in per unit equal to the apparent power actual in megavolt ampere over the base value of this. Yani for example, if you have such voltage here, the voltage here in power plant is 13.8 kilovolt, right? This is the rated.
Yes.
This is the rated value. But of course, the power system operator can operate the generation plant at different values of the voltage. It depends on, you know, the situation. Yani, maybe we need the voltage here to be 13.2 kilovolt, not 13.8. And for example, if we have over voltage at the load, if the voltage at the load increases, so let us reduce the voltage at the generator. We can control it, we can reduce it. So we can reduce the voltage at the load. If the voltage, this is the operating voltage. This is the rated, and this is the rated, and this is the operating value. And as you know, from 360, operating could be different than the rated, right? Yani
Yes,
if you have, for example, generation with 500 megavolt ampere, this is the rated value. And now, of course, if the load is 200 megawatt only, or if the load is 200 megavolt ampere, but the operating condition of this load generation, the generator will not, generate 500, but it will follow the load. It will generate only 200. So this is the operating value. So based on this, formula, if the operating voltage is 13.2 and the base value is 13.8, so the voltage in per unit equal to 13.2 over 13.8. This could give
0.956.
0.956 per unit.
Yes.
Yani you can say the voltage is 95.6%. The per unit is like a percentage value. Okay. So this is the way how to get the per unit quantities. You divide the actual quantity over the base value, or this. How many quantities in power system you use to handle with? We have the apparent power or complex power. We have voltage.
VAR.
VAR included in power, in complex power. Complex power includes the real power and reactive power. VAR, sorry, voltage, current, and the impedance. Okay, so these are the four quantities we use to handle in power system. So in per unit system, we used to select the rated power and the rated voltage, line-to-line voltage, as a basis. Arbitrarily, you can select any values, and if you select these values, then you can calculate the base current and the base impedance. We cannot, of course, select all the quantities arbitrarily, and these quantities are related to each other. And you can select only two as a basis, and then you can calculate accordingly the base current and the base impedance. And I base equal to S base, which is selected, over square root of 3 times V base. This is, this formula from 360 or three-phase calculation. How much is Z base?
V base square of S base?
Z base, yes, of course, but let us go from scratch. We can say Z base equal to V base over square root of 3. Why square root of 3? And we select here V base as a line-to-line voltage. Impedance is defined per phase. There is no line-to-line impedance, right? So this impedance should be per phase, and you have to convert the voltage per phase. Usually the default connection is Y, so the phase voltage equal to line-to-line voltage over square root of 3. So if you divide the phase voltage over the phase current I base, you get a Z base. If you replace I base here, you can get the impedance equal to V base square over S base. The square root of 3 here will go with the square root of 3 here. So you will find the V base square over S base. If you take the V base in kilovolt, so it will be kilovolt square. And if you take the S in megavolt ampere, so this mega will go with the kilo square. So V base square over S base square. So in per unit quantities, you select S base and the V base arbitrarily, and you can say no V base equal to 100 megavolt ampere. The V base equal to 13.8 kilovolt arbitrarily. And based on this, you can find I base and you can find Z base here. And you can convert definitely any quantity to the per unit quantity now. So the per unit quantity equal to the actual quantity. If you are given the impedance in ohm, then you can divide the impedance, the actual impedance over the base impedance calculated earlier. For example, S per unit equal to S over S base, V per unit, I per unit, Z per unit. Numerators are actual values, are either phasor quantities or complex numbers. Yani this is complex number. Yani could be this S could be B plus JQ. This voltage, magnitude and angle, V with angle delta. And this impedance also R plus JX. And the current also current I with angle delta. So numerators are actual values and could be phasor quantities or complex number. And denominators base values and are always real numbers. This S base is 100 megavolt ampere.
Doctor,
There is no an angle involved here. The V base also as such. Z base is just real number and I base is a real number. Yes, please.
The base value is the same as the rated, isn't it?
Usually you select the rated as a base. In principle, you can have any arbitrary value. Is it clear?
Okay.
To simplify calculation, you take the rated values as a base. In principle, you can choose any value. Okay? طبعا يعني to simplify the calculation, you select the base value as the rated values. Let us take this simple example here, which is just added this morning. Consider a three-phase power transmission system that deals with the power of the order of 500 megavolt ampere. This is the power, or this is the complex power, or the apparent power with the nominal voltage 138 kilovolt. We arbitrarily select S base. Of course, as I mentioned, then it is to simplify calculation, you take the base value is equal to the rated value. S base equal to this. Nominal voltage equal to low as a base voltage. So base voltage equal to 138. Can you calculate the base current? Base impedance?
Yes.
And if the actual voltage is 136 kilovolt, this is the operating voltage. Can you get the voltage in per unit? How much the voltage in per unit? Of course, this is just illustrative example. You just apply the quantities or formula given before. Yes, yes, please. Do you have a question?
No, doctor.
طيب, I base equal to S base over square root of 3V base. So this is 2.09 kilo ampere. This is the base value. Z base, V base square over S base, 138 square over 500 megavolt ampere. طبعا this is in kilo and this is in this value in kilovolt and this is in mega, so they are go together. So we have 38.1 ohm. This is the base impedance, and if the actual voltage is 136, and you take the base value equal to 138, so that means the voltage in per unit is 0.9855. Okay, clear? Just illustrative example. So let us take another example. For this simple system, the generator is rated as 350 megavolt ampere, 13.2 kilovolt, and the reactance in per unit, is 0.14. So find the base current. How much is the base current? I think it is straightforward, similar to what we have, give before. It is S base over square root of 3 V base, and if you take this as a base value, and this is a base value, so you can get easily the base current. What is the generator reactance in ohm? We should
find the base.
Sorry?
The base reactance. We should find the base reactance and multiply by the per unit.
Exactly, yes, you are right. You are given here the per unit quantity, and we need the actual value. We need the actual value in ohm. So you need to get the Z base, and then we can substitute as follows. S base equal to, and V base equal to this. I base equal to this 15.3 kilo ampere. Z base equal to 13.2 square over 350.5 ohm. X per unit equal to the X actual over Z base. Then you have X actual equal to per unit quantity multiplied by Z base, so it gives you 0.07 ohm. Is it clear?
Yes.
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 Okay, great. And I would like to give you just a very small online quiz, and I would like to, when you use the mouse with this tablet, it gives problematic issues. Sometimes the mouse is not appear in the other screen. So we will go to this, and we will go to the assignment, and then we'll go to the drafts, and then we will issue this. Okay, now I will give you about 3 minutes to finish this. Now it is
here in Teams or in Blackboard?
يا دكتور وين نشوف؟
علق عند الدكتور اتوقع.
وش الدكتور يقول الكوز يعني؟
البورد والتيمز.
وش الكوز هذا؟ ما قال لنا طيب من قبل انه في كوز.
هو تكلم كان قال لنا شو اسمه تقريبا كل اسبوع بيكون في كويز، بس ما قال لنا بيكون زي سبرايز زي كذا.
ممكن بس عن اللي اخذناه هذا اللي قاعد يصير الحين.
وين بيكون الكوز الحين؟
شوف البلاك بورد دقيقة. شوف البلاك بورد.
اتوقع بخليه على تيمز زي اخر مرة.
Are you hearing me شباب؟ Are you hearing?
انقطع الصوت.
On the teams or the blackboard, the quiz.
No, the themes just now. I will give you. Yeah, we have now 140. So this would be. I'm just setting the time to 143. Okay, I will assign it now. So you will find it on the general channel. Do you have it now?
Yes. Yes. Yeah.
So please go and answer it and submit it as soon as possible.
It didn't open for me, doctor. I don't know why. It's like a blank page.
Well, if this is the case for others, I don't think, maybe you have some problem in internet or something like this. Did it open to you, with you? Okay. So let us continue with the advantages of per unit system. Per unit values are simpler, and instead of hundreds of kilovolt and megawatt, megavolt ampere, and so on, you are now dealing with the quantities in order of one or point fraction or very low values, so it is much easier. And more indicative, what does it mean, more indicative?
Doctor,
Yes.
We can't see your screen.
Okay. Can you see it now?
Yes. Yes.
Yes.
Okay. Let me برضو. طيب, as you can see here, the per unit quantities are very simple. Order one or just fraction. Indicative, more indicative. More indicative, لأنه of course when we say, for example, the voltage is 145 kilovolt. So you can say, you can ask and what is the rated value. I need to know the rated value in order to judge whether this value is high voltage or low voltage or what is rated. So if you are given a voltage is 1 per unit, it is indicative that indicates that the voltage is equal to the rated. 0.95 means 95% of the rated and so on. So the per unit quantities are indicative. You know, the voltage, impedance, currents are the same in per unit, whether it is in, you know, in the primary side of transformer or secondary side in transformer, in per unit they are the same. So transformer now is no longer a problem. Then the per unit quantities are the same. We just replace transformer by the per unit reactance, and you analyze your network straightforward. Since the typical power system contains thousands of transformers, this is non-trivial saving, of course, very complicated. The factor of square root of 3 factor in the 3-phase circuits also is eliminated. The voltage phase per unit هو نفسه الفولتج line to line in per unit. But this is also will simplify the calculation. So this is just a brief overview of the per unit quantities. طبعا of course there are a lot of issues in per unit quantities, but this is not needed in our course now. So by this I think we finish this class, and if you have any question, please. Otherwise we end the meeting.
Doctor.
Yes, please.
We don't like this kind of quiz. We need to study and then take the quiz.
Yes, the quiz here is not, you know, is not for, one of the also objective of that quiz. I don't need the actual answer, maybe. In this quiz specifically, I don't need the actual answer or the correct answer, but I need to know who is with us, or who is physically with us, and who is virtually only with us. So this is also another objective of the quiz. Even if you did you know, a wrong answer, it is not a big issue for such quizzes. Okay, but of course you have to do your best. In some quizzes, we need the correct answer. I know, this is this you know, quiz you have to study first in advance and so on. So maybe we can it would be better to postpone it to the next class and so on. But for this, I need, as I mentioned, we need to know who's is physically with us also, not only virtually. Is it clear? Any other question?
Doctor, is this introduction to this course or a review for power protection?
This is the introduction to the course. And when I asked you, did you take 463? So many, they didn't take 463, so they are not covering this per unit. And I added this per unit values here. It is not in the course, but it gives you, you know, when we say voltage equal to 0.95 per unit, later on when we have this optimum power flow or security or so, in this case you you are aware about the per unit system. So this is this is not in the course. And the course will start the next class with the load forecasting issue, and I have posted the material of the load forecasting in the Blackboard. And also I have announced about the office hours. I will open the meeting in 8:30, and you can join if you have any question. And if you find the meeting is not started yet, then you can call me through the Microsoft Teams to log in and discuss. Is it clear? Any other questions?
Doctor, so this quiz will not count.
Yeah, it will not count this. It counted maybe for the absences. And maybe from this exam, the absences will be taken. Who responded, who not? Any other question?
Thank you.
Okay, thanks a lot. See you on Monday, inshallah, on Wednesday, inshallah. Sultan. Sultan. Sultan Faib. So you are not there.
Yes, yes.
Yani, why you didn't log out till now? I need to close.
Okay.